Hello everyone, I am Jomina John, Assistant Professor, Department of Computer Science and Engineering from Rajagiri School of Engineering and Technology. The subject I am going to deal with is Principles of Database Design, which is applicable to S4 Computer Science as well as IT Department student. Here, today I am going to deal with indexing concept, which is that first topic in Module 5. In the indexing topic, I will be dealing with single level indexing as well as multi-level. In the single level itself, there are mainly primary, clustering as well as secondary level of indexing is there. So first we will see what is exactly an indexing is. Suppose I want to search a word, say for example, the word clustering, I want to search it in a textbook. How can I search it efficiently is, I will look into the index which is given in the last part of that textbook. In that one, it will be normally all the special words will be given in an alphabetic order along with its page numbers. So I can search for that cluster word alphabet starting with C. In that one, I can find different page numbers under that one. From this different page numbers, I can see that wherever the word clustering is referred and the details of that one if it is provided in the textbook. So that is what the advantage of using an index in a textbook. Similarly, when we are considering a database, huge amount of data will be stored in the disk. So whenever we are processing a query, we have to access that particular data from the entire database. In the database, there will be huge amount of data will be there. So here using indexing, what I am trying to do is that I am going to create an index for the already existing database so that the query, using the query retrieval process, the extraction of data from that one will be very simple one. So we will go to the definition. Here you can see indexing. It's a way to optimize the performance. Performance can be optimized. How it will be optimized? By minimizing the number of disk access required when a query is processed. So it is the data structure technique itself we are using through which we can easily locate and access the data in the database. So that is what indexing in database means. I told you different types of indexing is there. Indexing can be an access path. That is, access path means in order to access something, the path, say for example, I am storing a file in a C drive, I have to specify the path for that one. Same way, index is working like an access path. How it is working is, suppose if I am considering a single level index, that is an index is provided to a database. Through the index, I can access wherever the data is stored in that database. So normally how it will be is, along with the database, say consider for an company database, I have an employee table. I am creating an index for that employee table. Okay. So the index may be, normal case, it will be a file, a data file, or a particular field will be attached to that database. It will have mainly two values, a field value and a pointer. Field value indicates the entries in the database so that each record in the database can be uniquely identified, and from that one, how to go to that one, that is a pointer will be there. That's why the index is called an access path on that field. So normally database will consume large amount of space in the disk. Along with that one, we are going to create an index file. So it should be a very small file we have to create so that it will consume considerably less block space. So there will be an index. From that index, first of all, I have to find out the corresponding field value through which I can access the data in the database. So normally it will be an ordered one so that I can perform binary search on that one. Normally two types of indexing can be possible. It is not type. The index can be characterized as two ways. They are dense index as well as sparse index. suppose a employee table is there, 100 employees details, 100 employees records are stored in that one. Suppose I am creating an index for each 100 one, that is known as dense index. Suppose if I am creating an index for some of them only, through which I can access the entire record, that is known as sparse index. So two types of indexing is there, dense index as well as sparse index. Dense index means for each and every key value, I will have an index value for each and every value in the data file, whereas in sparse index, there will be some of the search entries will be present in the index file. That is known as. So we will start with the first type of indexing, that is under single level indexing. First type, primary indexing. So normally primary indexing, from the word itself, it is related to primary key value, and normally in an ordered data file based on the primary key, we are defining primary indexing. In primary indexing, there is one more concept is there, and block anchor concept. Okay, and normally in primary indexing, we will be using sparse index. Sparse index means only for some of the entries we will create search key in the index field. So before moving to the detailed definition of all these things, I will explain it with an example. So this is a primary indexing example. Okay, here this is an employee table. Different fields are there: name, SSN number, birth date, job, salary, etc. Here considering name of the employee as the primary key. Normally name will not be a primary key, but here name is unique, so I can consider name of the employee as the primary key. So this is my primary key, and you can see that it is ordered, alphabetically ordered, this one. So this is what our index created is. So I told you index will have two parts, a field part and a pointer which points to that particular database. So here you can see each database records are divided into different blocks. Each block contains 4 records. Here you can see in each block 4 records are stored in that one. So starting with the first one, this is arrow ED. Arrow ED index field is present here. From that one I am pointing to the first entry in the first block. Similar way, second block to the first entry I am pointing. So here you can see for each entry there is no index. That's why for some of the entries only there will be index is present. So that is known as, I have termed it as sparse index, not a dense index I have created. This is known as anchor, block anchor, that is pointing to each block first line. That's why it is known as block anchor means. Okay, so this is ordered based on a primary key value. So that is known as primary index, and ordering is there based on the primary key field. Okay, so for each block we'll have a fixed size of 4 and an anchor will be pointing to each block first line. Okay, we will see the definition one more. Primary index normally defined an ordered one and ordered on a key field. It includes one index entry for each block of the data file. So for each block we have an index, and the index entry has a key field value for the first record in the block, which is called block anchor. That is, for the first entry it is pointed. So the same is applicable up to the last record. Primary index, normally we will be doing sparse index, because for each block I have one index is there. Okay, we are moving to the second type, that is known as clustering index. Clustering is also we will be doing on ordered data file, but ordered one in a non-key based one. It is not a primary key or a key value I will be using. I will be a non-key field will be using there. Okay, how it is we will see after that the definition. So this is what an example of a clustering which is based on department number. Here you can see department number 1 is there, 2 is there, 3 is there. So that is department number is not a key value, but it is a clustering value. That is, we can group all the records according to their department number. So there are 3 records are there belonging to department number 1. There are 2 records are there belonging to department number 2. Similar to the primary one, it is also divided into blocks of 4 size. Here you can see department number 1, 3 entries are there. Another one is 2, I am starting here. Okay, in the same block itself, without leaving any space, I am starting the 2 here itself. So how the index will be, department number 1 is there, 2, 3, 4, 5, 6, then 8 is there. So for each different value, each different group, I have created an index. That's why for different clusters are there, that's why it is known as clustering index. For each cluster, we will have a pointer, block pointer will be there. One is pointing to this one. What about 2? 2 is actually starting in this block itself. That's why it is pointing to the same block itself. 3 is starting in this one. That's why it is pointing to this one. 4 is starting in this one. That's why here. So it is nothing but clustering we are doing. It is also a sparse since for each entry I don't have an index. Okay. Clustering can be possible with one more case, that is, here one disadvantage is that if one more department number 1 entry I have to add, there is no space. So I can make each cluster separately. That is, if one more space is there, I can leave a space there. This is another one that is known as clustering index itself with separate block cluster. For each cluster we will have separate block. So one there is 3 entry, 4th one I have left it blank and the block pointer will point to the null pointer. 2 there are 2 entries are there, rest 2 I have make it as blank and block pointer will point to the null pointer. Likewise it is continuing. For the 3 there are actually 5 different records are there, 4 I will fill it in a block, another block will be continuing. So that's why this block pointer will point to this particular one and its block pointer will point to a null value. Likewise, it will be continuing. For each one I will be creating. So we will go to the definition of clustering. It is also ordered one, but it is a non-key field unlike primary index we are taking here. For each distinct value we will be having an index there. Include one index entry for each distinct value of the field. The index entry points to first data block itself, similar to the primary one. Okay, that is clustering. Next we are moving to the secondary index value. So here in the secondary index value, normally when we are going for the secondary index, already primary access is there. I am going to create a second to the primary access. That is, I have created a primary access. One more accessing I want to add one more access. Normally we will go for secondary accessing. Okay. So normally how we can do is that mainly 2 types of secondary accessing is possible, with the key value and without key value. How it will be doing, we will see with an example after to this definition part. So this is my definition, dense secondary index part. Here you can see this is not a primary key value, this is a secondary one. So it is not an ordered one, but it is a key value. Key value means it is unique one. So I am creating an index like this. One is pointing to this particular block. Second one, 2 is pointing to this particular one. And in this block itself, next entry is 10. 10 is pointing to this one. So after one pointer, I will point this 10. Next one is 20 is there in this same block. 20 will be pointing to this one and 24 will be. So here you can see this is a key attribute that is unique itself, but it is not an ordered one because it is ordered based on the primary key value. Okay. And you can see that for each entry there is an index is there. So that's why it will be dense, not sparse, it will be dense. That is, for each and every entry there will be an index present. Index itself, it can be a non-key value also possible. Key value and non-key value. Here non-key value, that means same entry is present two times. So for example, two times. Here you can see one is present in two times. So how we will point out it is as this is my index file. Index file will have a block pointer to another one. Here we will have pointers which point to different blocks. This one is pointing to this one. This one is pointing to this, and this is to this one. So three ones are there. So for each one I have created a pointer. So since this is a non-key attribute, the values will be repeating there. So this is a secondary index on a non-key field. Okay. So that is what created here. Okay. Have unique field values will be there. So for each one I have created like that. So secondary index, two types with the key, with the non-key. That is what index in an ordered file with two fields. The first field same data type as some non-ordering field of the data file, that an indexing field. Second field is either a block pointer. That is, if so many is existing, it will have a block pointer. There can be many secondary indexes can be possible since so many entries are there, if there is. So it is normally dense index we are creating index. So this is actually a comparison table. Primary is non-dense. So how many blocks are there? For each block we will have a index. So that is non-dense value. For each block we are pointing out. Clustering, for each block we will be doing. For distinct one we will have each pointer will be there. So that is non-dense itself. So in the clustering we will have block anchoring itself. Yes. Sometimes it will have a no value. That is, if distinct value of ordering field starts with a new block. For each one, each block if it is assigned. Secondary can be of two types, key value as well as non-key value. If the key value is there, for each number of records, that much of index entries will be there. That will be dense. Secondary non-key value means for a single entry there will be duplication of that one. So depending upon it will may have number of records or number of distinct index field values will be there. So it can be dense or non-dense will be there. Okay. Next one is multi-level indexing. Multi-level indexing means suppose first level of indexing is already there. I am going to create an index for an index. That is, already an index is there. I am going to create an index there. That is known as multi-level indexing. With an example, first we will come back to the definition. Okay. Here I am creating, this is my index. This is my table. So with the primary indexing, I have created an index. For that index, I am going to create one more level of index there. That is this index. First primary index, I have divided into different blocks and creating one more level of index. That is known as second level of indexing for this one. That is indexing for an already existing index. This is applicable normally in the case of huge amount of data is there. So index will be very large. So index will be divided into blocks. I can have a second level of index. Likewise, a third level, fourth level, like that levels of indexing can be possible. So we will see the definition. Single level index is an ordered file. We can create primary index to index itself, creating an index to the index itself. So original index is first level, another index created is second level. Like the third level, fourth level can be possible. Okay. So a multi-level index can be created for any type of first level index. That is, first level can be primary, secondary or clustering. To that one I am creating one more level of indexing there. So that is what we have seen. What is indexing? What is single level indexing? Three types: primary, clustering, secondary. Then what is multi-level indexing? That's all for today.